Good evening, and welcome to the Song of Urania, a podcast about the history of astronomy with new episodes every full moon. My name is Joe Antonini. Tonight, we will be embarking on our journey through the history of astronomy, and starting with the earliest civilization that left detailed written astronomical records, the ancient Babylonians. But before we start describing exactly what the ancient Babylonians discovered, and how, we should start by taking a more general look at the attitude of the ancient peoples towards the heavens. Because the ancient peoples looked at the heavens differently than we moderners do today. The main difference is, they actually looked. Almost every person listening to this today is living in a city that is incomprehensibly larger than the cities of the ancient world. Even a modest town by the standards of the 21st century world would be at least an order of magnitude larger than the largest metropolises 4,000 years ago. And it is not simply the population that is important. Today's cities differ from their ancient forebears in the quality and quantity of their illumination. Around the early 19th century, cities began illuminating streets during the night for the safety of their citizens. With the invention of the automobile, nighttime illumination became an even more pressing issue of safety and good government. Today, anyone who has traveled by plane knows that you are getting close to landing at night when you start to see more and more lights out the window. We can viscerally see the lack of development in North Korea relative to its southern neighbor just by looking at satellite photographs of the two countries at night. But these city lights don't simply illuminate the streets below them. They reflect up off of the streets and then scatter into the atmosphere. This illuminates not only the street, but the sky above it, and washes out the stars. In a 21st century city, it is possible to see some stars, but not many. In a way, this is maybe more unfortunate than losing the stars altogether. If we couldn't see any stars at all, we would at least know we had lost something. But because we can see a few stars, we don't realize how much richer the sky is without the ambient light from the city. Well, it was not so in the ancient world. Without the profusion of artificial light, the nighttime sky was far richer even in the center of the world's largest cities than most moderners realize. We moderners must make a concerted effort to view the sky as it was seen by our ancient forebears. We must travel hundreds of miles away from the nearest outpost of civilization to escape the illuminated skies we've created for ourselves. And even then, hundreds of miles away from the nearest city, its glow can usually still be seen on the horizon. But most of us moderners have never gotten this far from civilization and have never seen what a really dark sky looks like with our own eyes. And even those of us who have gone camping or otherwise escaped to the wilderness and seen with our own eyes the richness of a truly dark sky are missing something. Because those of us who see it when we are camping only see it when we are camping. What is qualitatively different about the ancient world is that the richest, darkest sky we have ever seen is what the sky always looked like for everyone, every night of their lives. When we see the shapes of the constellations and think that they don't really look anything like what they're supposed to, and you need to have a pretty good imagination to think that that cluster of stars over there looks like a dog or a lion. What we fail to understand is that the ancients didn't see that group of stars every once in a while when they could escape from it all. They saw those stars every night from birth to death. It takes some effort for us moderners to recognize the constellations, but to any of our ancient forebears, knowing the sky intimately was the most natural thing in the world. How early did humanity recognize the stars of the sky? Well, we can only imagine it dates back to the very dawn of humanity tens of thousands of years ago. But unfortunately, we have little conclusive evidence for much of anything about the way of life of early humanity, nevertheless the astronomy of the earliest peoples. Which is a shame, really, because some 90% of all people ever to have lived during this prehistoric period. So it would be nice to know more about them than we do. But as they did not leave much evidence for us to go off of, it's hard to rigorously conclude much about them. In a future episode, we will spend some time doing some discussion, mostly speculative, about the astronomy of prehistoric peoples, but for the time being, we will stay on more solid ground. So we have to imagine that the forebears of the ancient Babylonians had created constellations and associated myths with those constellations, just as has every culture that has walked this earth as far as we know. And we can actually find some circumstantial evidence for constellations going quite far back, possibly as far as 20 or 30,000 years in the past. But the further we go back, the sketchier the evidence gets. So we will start a little bit later than that, some time after writing had been developed in Mesopotamia, with an inscription in a temple constructed by King Gudea, sometime around 2130 BC. This inscription describes King Gudea's inspiration for building the temple. It reads, quote, "My shepherd," said the goddess, "I shall read for you your dream. The man whose stature filled sky and earth, whose crown proclaimed him a god, and at whose side was the imdeged bird, storm at his feet, and to right and left 2 lions, was the god, my brother, Ningirsu. His command to you was to build his temple and Inu. Now the sun that rose from the earth before you was your guardian god, Ningitida. Like a sun, his serpent form rises from the earth. The woman holding a stylus and tablet of constellations, wrapped as it were in thought, was the goddess, my sister, Nisaba, showing to you the auspicious star for your building of the temple. The second man, a warrior, with lapis lazuli tablet, was the god Nindub, designing for you the temple's structure, and the ass, laden at the right of the king, that was yourself, ready for your task." End quote. The description of this auspicious star tells us that the heavens were of astrological importance right back to the very first records we have of the stars. But even more interestingly, the description of the woman holding a tablet of constellations seems to suggest that a fixed set of constellations had been developed in Mesopotamia by this point. Another important source of evidence comes from cylinder seals. We have, from later records during the Neo-Assyrian Empire, more than 1,000 years later, around 900 to 600 BC, much more detailed descriptions of the constellations of this region from a variety of textual sources. But in addition to those sources, we have cylinder seals from that era which depict the constellations described in these other documents. Cylinder seals are small cylinders, usually around an inch or so high, with engraved images around its side. The cylinder could then be rolled onto a surface of wet clay to imprint the image. Cylinder seals were used for a variety of purposes, artistic and religious, but were also an early form of signature. By the time of the Neo-Assyrian Empire, there is abundant evidence that the gods were associated with various celestial objects, particularly the planets. From these associations, we can start to match certain figures seen on cylinder seals to the corresponding celestial object. Some of these are fairly obvious. A lunar crescent represents the moon. 7 dots represent the Pleiades. A less obvious symbol, but one which other documents make clear, is the goddess Inanna Ishtar for the planet Venus, and a lion for the sun. In some cylinder seals, Inanna Ishtar is depicted seated on a throne with a lion on a leash, representing the observed fact that Venus is never far from the sun. One might suspect that this is reading into the symbolism a little too much, but some of these seals are really quite replete with astronomical symbolism. Not only is Inanna Ishtar pictured with a lion, the sun, but a lunar crescent as well, along with the god Adad, standing on a bull, which is the modern constellation of Taurus, and a creature half man, half scorpion, representing the constellation Scorpius. Other seals contain a second lion next to a pair of objects, sometimes date palms, which represents the constellation Leo, next to the constellation Gemini. Sticklers may object that this skips over the constellation Cancer, but Cancer is a much fainter constellation, and it was likely identified later once astronomy had developed enough to recognize the importance of the zodiac. The interesting thing about these cylinders is that although the written corroborations of these astronomical interpretations are more recent, cylinder seals with very similar symbolism go back much further, before we have any real written records of the specific nature of the constellations. So it is plausible that by 2000 BC, the Babylonians had identified a set of constellations, many of which are similar to the constellations we identify today. Now, of course, we must always remain open to the possibility that the stars identified with these constellations changed over this period of 1,000 years. We don't exactly know what constellations the Babylonians of 2000 BC had identified. We only have some evidence that they had identified some constellations. But it is certainly plausible that the constellations remained fairly static over this time period. The eye is, after all, naturally drawn to certain groupings of stars on the sky. We see that cultures across the globe have independently associated the same groups of stars together into constellations. The Big Dipper, Taurus, Scorpius, and other constellations have been variously recognized as distinct constellations by cultures as far-flung as the ancient Babylonians, the Javanese, and the Hawaiians. In some cases, disparate cultures have even independently associated these constellations with the same mythic creature. The ancient Greeks identified Orion as a great hunter, as did the Seri of northwest Mexico. Moreover, the motion of the moon naturally enhances the importance of other groups of stars. The moon changes its position on the sky over the course of a month, but it doesn't just move randomly around the sky. Its motions are constrained to lie within a fairly narrow band of constellations on the sky. In fact, it doesn't take too much observation to realize that this is true of all the planets and the sun to boot. No matter where they move, they all appear against the background of this narrow band of constellations. Today we call this band of constellations the zodiac, meaning the circle of the little animals. The reason being that most of these constellations are animals. Historically, for reasons we'll go into in a future episode, the zodiac contained 12 constellations. But today, strictly speaking, a 13th constellation, Ophiuchus, actually overlaps with the zodiac as well. But even prior to the systematization of the zodiac, the ancient Babylonians recognized the regular path of the moon across a certain set of stars. Since a month is approximately 28 or 29 days, they identified 28 small groupings of stars, approximately equally spaced across the moon's path, that they could use to trace the moon's progression through the month. This way, in addition to simply counting the days since the last new moon, ancient Babylonian astronomers could determine which grouping the moon was closest to try to figure out how far into the month they were. This is much more accurate than trying to estimate by eye how close to full the moon is, or how close to first or third quarter. These groupings of stars are variously known as moon stations, moon houses, or moon mansions. And it is not clear that these moon stations were originally developed by the ancient Babylonians. The concept of moon stations was also present in Indian and Chinese astronomy, and these three cultures identified almost exactly the same moon stations as each other. It's unknown whether one of these cultures developed it first, and the concept spread from there to the others, or if they identified the moon stations independently and happened to come up with the same groupings. After all, they were looking at the same moon and observing the same stars. Now, if you had looked at the sky with some attention, and of course you would have if you were living in the ancient world, you would have noticed that in addition to the motion of the moon, the sky itself slowly changes over the course of a year. The constellations that are visible to you change from season to season. Someone in the northern hemisphere, say around the city of Babylon, who looked straight up after a sunset in the early summer, would have been looking at the modern constellation of Boötes, the herdsman. But by early fall, Boötes would no longer be straight above, but low on the western horizon. Instead, after sunset, straight above you would be Cygnus, the swan. By early winter, Boötes would no longer be visible at all. By the time spring came around, Boötes would now start to be visible low on the eastern horizon, shortly before sunrise. Ancient peoples were well aware of this gradual annual change of the constellations, and they would look at specific stars and use them to keep track of the seasons. At one point during the year, a star would be observed directly overhead right after sunset. Over the course of the night, it would then sink towards the west around midnight. But with each passing day, right after sunset, it would be seen to be slightly lower towards the western horizon. It would then be visible for a slightly shorter period of time. After several months, it would only be briefly visible low on the western horizon shortly after sunset before following the sun below the horizon. Then it would disappear entirely for some time, usually several months. Eventually, it would be briefly visible on the eastern horizon just before sunrise until the sun rose along with it and washed it out in the sky. As more time passed, the star would rise earlier and earlier in the morning until it was once again overhead at sunset, completing the annual cycle. The day of the year on which the star was first visible after the months-long period of having disappeared from the night sky was of crucial importance to the ancient peoples. It was so important that we give this event its own name, the heliacal rising. By looking for the heliacal risings of various stars, ancient peoples had a very accurate way of charting their progress through the year. The Babylonians used this technique to great effect. There is a tablet listing 36 stars, roughly evenly spaced east to west, that were used to keep track of their progress through the year, so that there were roughly 3 heliacal risings every month. And there is a reference to these 36 stars in the great Babylonian creation myth, Enuma Elish, which was recorded on 7 clay tablets sometime between 1900 and 1600 BC. One portion of it describes the acts of the greatest god of the Babylonians named Marduk, and reads, quote, Marduk made the stations for the great gods, the stars, their images, the constellations he fixed. He ordained the year, and into sections he divided it. For the 12 months he fixed 3 stars. The moon god he caused to shine forth, the night he entrusted to him. He appointed him a being of the night to determine the days. End quote. So very early on, the Babylonians had developed a very systematic way of tracking these heliacal risings. But this technique was by no means limited to them. Cultures across the globe have looked for the heliacal risings of particular stars to mark the beginnings of certain seasons and observe certain rituals. The Egyptians looked for the heliacal rising of Sirius to mark the beginning of their calendar. Much further east, the Aboriginal Australians and Maori of New Zealand used the heliacal risings of the Pleiades star cluster to mark the beginning of winter. And the Javanese used the rising of Orion to mark the beginning of the working season. Conveniently, from the southern hemisphere, Orion is shaped rather like a plow, so if there was no plow visible in the sky, they did no work. Heliacal risings are an important feature of ancient astronomy, and we will talk much more about them in future episodes. But this perhaps raises the question of why these heliacal risings are so important to so many cultures. It does seem like a bit of a bother to keep track of them. Perhaps the ancients had nothing better to do with their time, but maybe we can come up with a better answer than that. And there are 2 answers that we can give. The first is simple and not really wrong per se, but it leads to a second, more complicated answer. The first answer as to why the ancients kept track of heliacal risings and, more generally, the months, was that it was important for agriculture. Agricultural societies needed to know when to reap and when to sow, and the sowing was the more important part here. Anyone can figure out when the crops are ripe and ready to be reaped, but when you sow, you can't do it too early, or else an early frost could wipe out the crop. But the harder part is that you also can't do it too late, or else winter may come and kill your crops before they ripen. We see the intimate connection between the months and agriculture through the symbols the Sumerians used for their months. The 4th month was the symbols seed and hand next to each other. The symbol for the 10th month was the symbols corn and cutting next to each other. The 11th month was corn and house next to each other. around the city of Ur, the 8th month meant loosening the plow. By no means do all of the months correspond to agricultural activities. The first month of the Babylonian year means month of beginning, and many of the months in various calendars in Mesopotamian societies refer to various festivals. But agricultural activities make a large enough presence that we can infer that the calendar was regulating these activities. And we see evidence for the link between the calendar and agriculture in other societies as well. The most obvious evidence for this is that many cultures didn't bother to keep track of time at all during winter when agriculture didn't take place. This was the case in Java and also in early Roman society. In fact, the vestiges of this practice remain with us today. You may have noticed that the month of September has the root sept for 7. But September is not the 7th month, it is the 9th. Similarly, October has the root oct for 8, but is the 10th month, and so on with November and December. They're all off by 2. And it's even worse than that because, in fact, August was originally called sextilis, and July quintilis, using the roots for 6th and 5th, respectively, until 2 Roman emperors decided to name those months after themselves. Well, originally these months were in the right place. September was the 7th month, October was the 8th month, and so on with November and December, and also sextilis and quintilis. There were only 10 months in the calendar. The Romans didn't bother to keep track of the winter months. January and February were later additions to the calendar. But they were originally added to the end of the calendar, so that September through December remained the 7th through 10th months. This worked because the Roman year originally began in March, at the vernal equinox. It was only later that the new year was put at the beginning of January and messed up the locations of September through December in the calendar. But I'm getting ahead of myself. We'll discuss the Roman calendar in much more detail in a future episode. The point is, we see a clear relationship between calendars and agriculture across many societies, including the societies of ancient Mesopotamia. So that is the simple answer to the question of why these societies kept track of heliacal risings and by extension the months. The difficulty with this simple answer is that it raises a natural question. Agriculture is highly dependent on the weather. Of course, there are annual weather patterns, but day to day, the weather is quite variable. An agricultural society needs to account for frosts and thaws when deciding when best to sow, and the last frost in a region can easily vary by several weeks. So why bother with the precision of heliacal risings if you only need to generally know the time of the year to within a few weeks? The answer here maybe gets a little hand-wavy, and perhaps we can't really say 100% for sure. But it seems that the need for this precision arises from the fact that as city-states started to grow to encompass tens of thousands of subjects, precision and timekeeping became necessary to coordinate the activities across this large group of people. It's simply not feasible to plan in advance with so many people without some means of synchronization. This was particularly the case for religious ceremonies. Most of the month names in ancient Mesopotamia that don't refer to agriculture refer to a festival. If you want everyone to stop working to enjoy a festival on the same day, you need some way to keep track of the days. Just knowing where you are in the year to within a few weeks isn't going to cut it. Where things start to get messy is that these societies in ancient Mesopotamia used the motions of the moon to keep track of the months, but also used the heliacal risings to keep track of where they were in the year. It is likely that the predecessors of the Babylonians, along with the other civilizations in Mesopotamia like the ancient Israelites, began tracking the motion of the moon prior to heliacal risings. We believe this because various religious festivals correspond to dates in certain lunar months, not dates with respect to heliacal risings. The heliacal risings, by contrast, correspond to dates for agricultural activities. It is probable that these cultures had adopted their moon-based religious practices prior to the time that they settled and adopted agriculture. Well, as I talked about in the last episode, this presents a problem, because the length of a month does not neatly divide the length of a year. So if you have 12 lunar months in a year, you will be about 9 days short. This means that the following year, the months will be 9 days earlier with respect to the seasons than they were the year before. And the following year, they will be another 9 days earlier, and so 18 days off from the first year. And each year will get another 9 days off. It doesn't take long before this starts to become a serious problem. After just 4 years, your calendar will be off by more than an entire month. Now, there are a couple of things that you can do when this happens. One is to just not care. This is the approach that the Arabians took and is still with us in Islam today. The Islamic calendar is a purely lunar calendar and consequently cycles through the solar calendar. Some years, the holy month of Ramadan is in the summer and the fasts are long, and other years, Ramadan is in winter and the fasts are shorter. Another approach is rather than stop caring about the solar calendar, stop caring about the lunar calendar. This was the approach of the ancient Egyptians and is our approach today. Now, the months don't correspond to the motions of the moon and only retain the vestige of the lunar influence in the fact that the length of the month is approximately the time it takes for the moon to go through its cycles. Sometimes a new moon is at the beginning of the month, or sometimes it's a full moon, but usually it's just somewhere in between. But neither of these two approaches will work if you want to care about both the moon and the seasons. And the ancient Babylonians did care about both. They cared about the moon, presumably for religious reasons, and they cared about the seasons for agricultural reasons. In this case, what the ancient Mesopotamians did, as did all cultures that have wanted to simultaneously use lunar and solar calendars, is a technique called intercalation. The idea behind intercalation is that most of the time you have 12 months in a year, but then the months start to drift earlier in the year, and then after a few years they drift too much, and you decide to have a special year with an extra 13th month. This then resets the months to their correct place with respect to the seasons, and gives you a few normal years for it to drift back before you need the extra month again. Initially, this process of intercalation was very ad hoc. Records from ancient Israel indicate that the priests would go out into the fields to inspect the crops 2 weeks before the appointed harvest time. If the crops appeared to be too far from ripening, they would declare an extra month. Ancient Babylonian priests did much the same thing, and would declare an extra month in the year when they felt that the months were drifting too far with respect to the seasons. Not coincidentally, this extra month would come before the harvest month to push the harvest back to the proper time. Early on, these extra months were somewhat surprise events and considered to be at the very least an unlucky omen. And even worse, sometimes this had to be done 2 years in a row. And occasionally, in exceptionally bad circumstances, the calendar had drifted far enough that the priests decided that it was necessary that 2 extra months be added in the same year. When this was done, one of the extra months was put before the harvest month, and the other was put after the 6th month, called Ululu. This second extra month was simply called Second Ululu, or Ululu II. In the period from 2000 to 1600 BC, there does not appear to be much evidence that these intercalations were planned for. In fact, we have a letter during the reign of King Hammurabi, which reads, quote, "Thus Hammurabi speaks. Since the year is not good, the next month must be noted as a second Ululu. Instead of delivering the tithes to Babylon on the 25th of Tashritu, have them delivered on the 25th of Ululu II." End quote. What is going on here is that this second Ululu needed to be added to the calendar, but existing contracts specified that the court was to receive taxes, which were at the time food like barley, on the 25th of Tashritu. Since this second Ululu month suddenly appeared, food to the royal court would be delayed by an entire month unless the contract was revised. Adding an extra month to the calendar was not a trivial affair. Proclamations had to go out, contracts had to be revised. It could potentially be a mess. So now we start to see some of the value of keeping track of heliacal risings. Although for basic agricultural purposes it wasn't so important to keep track of the progress through the year with great precision, once you have a whole society that needs to stay coordinated with itself, keeping track of heliacal risings could give the priests advance notice as to when the months are starting to drift from their proper locations in the year and give them time to plan for the addition of the extra month. By roughly 600 BC, the Babylonians had discovered a regular pattern that seemed to keep the months more or less in sync with the seasons. This cycle, called the Metonic cycle, lasted 19 years, and in it, the 3rd, 6th, 8th, 11th, 14th, 17th, and 19th years all had the extra 13th month. The rest had the usual 12. So over the course of 19 years, you would have 235 months. This is in fact very close to the actual number of synodic months that are in a year. It is only off by about 6.5 minutes. Or to put it another way, the calendar drifts by only 1 day every 219 years. So once the Babylonians had hit upon the Metonic cycle, along with other civilizations of the Near East like the ancient Israelites, it served them well for a very long time. But we will get into that more in a future episode. Now, you may have noticed that at certain points during this episode, I've been a little vague about dates. Or when I've given dates, I've provided a very wide range encompassing many centuries. Unfortunately, the ancients rarely dated the artifacts that they left us. And even when they did, they of course did not use a dating system that is at all useful to us. In the ancient world, particularly in the earlier periods, years were counted based on how many years it was into a particular king's reign. So you would say that these events, this war, occurred in, say, the 7th year of King Hammurabi. Unfortunately, this system treats each king as being a completely independent timekeeping system. If you know that one event occurred in the 7th year of Hammurabi and another occurred in the 3rd year of Gudea, you have no idea how far apart these two events occurred, or even which one happened first. The only way to piece together absolute dates is to put together a chronology of the kings in the empire, and you have to be sure to get the lengths of their reigns correct, because any errors will affect all of your dates thereafter. And it goes without saying that you'll be in real trouble if you missed any kings. Now, this was as much an issue for the ancient Babylonians as it is for us today. By the time of the Seleucid Empire, around 300 BC, the scribes must have gotten sick of keeping track of how long ago particular events occurred, maybe after a string of especially short-lived kings, and by this point started to keep track of continuous stretches of time marked from a single date, just as we do today. They used the beginning of the Seleucid dynasty, and this period has come to be known as the Seleucid period. But how do we correspond the start of the Seleucid period to a year we are familiar with in the modern Gregorian calendar? Identifying absolute dates is a very, very difficult problem in archaeology, particularly when dealing with events this far back in the past. Over the decades, archaeologists have been able to add tools to their toolkits to help establish a proper chronology, radiocarbon dating, records of king lists, correspondences of events with other cultures, tree rings, and astronomy. Astronomy has played a really unique, maybe strange role in the establishment of this ancient chronology. The kind of evidence that astronomy can provide in establishing the chronology of ancient Mesopotamia is important enough that it's perhaps worth at this point digressing a little bit to talk about this role. Now, up to this point, I've been telling this history with a sort of view from nowhere. I, the narrator, am simply transmitting facts to you, the listener. These are facts that, in this telling, historians and archaeologists, in all their erudition and careful scholarship, simply know to be fact. But of course, these facts were not always known. Indeed, after the fall of the Roman Empire, not much at all was known about Mesopotamia in the West. The only ancient texts that Western scholars had access to were some Greek texts, which largely came via the medieval Islamic empires, and of course, the biblical texts. Thanks to those biblical texts, during the Middle Ages, scholars in the West knew of the existence of various ancient peoples in the Near East, like the Babylonians and Assyrians, but they didn't know much more than that. In fact, it wasn't until the 12th century that the Jewish traveler Benjamin of Tudela rediscovered the ruins of the city of Nineveh. During the medieval era, Nineveh was best known from the book of Jonah as a city filled with sinners that comes to repentance thanks to the somewhat reluctant efforts of the prophet Jonah. But of course, in the ancient world, the perceptions of a minor kingdom in the Levant called Judea were not especially important. In the decades prior to 612 BC, Nineveh was the largest city in the world, a metropolis of enviable wealth, the capital of the great Assyrian Empire, and a center of world culture. Yet, by the Middle Ages, next to nothing was known about this city, not even its location, until the travels of Benjamin of Tudela. And Nineveh was not unique. So it was with the other great cities and empires of the Near East. Some description existed in the Hebrew Bible, but of course, the biblical texts are more theological in nature, and when they wrote their histories, they wrote them from the particular point of view of the Jewish peoples in the Levant. The various empires that they interacted with were mostly portrayed as havens of sin and idolatry, sources of destruction and ruin, wretched hives of scum and villainy, if you will. Modern theologians tend to read these texts metaphorically, with Babylon being a symbol of sin and its capacity for spiritual destruction. But given that these empires were rivals of the ancient Israelites, the original intent was likely quite literal. A few Greek references to these ancient Mesopotamian empires had also survived, but they were few and of dubious quality. European knowledge of ancient Mesopotamia did not really progress for many centuries. Every now and again, a European traveler to the Near East would report on what he saw, and several of these travelers reported a strange kind of writing on the inscriptions of buildings and monuments. But serious attempts at deciphering this writing, called cuneiform, did not begin until the Enlightenment in the 1700s. Copies of some of these inscriptions were published in Europe in 1711, and a much larger tranche of inscriptions was published in 1767. Well, after all of this effort, by the end of the century, European philologists had deduced the word for king. Things really took off in the 1800s, though, as Napoleon's invasion of Egypt brought back a tremendous number of ancient sources to Europe. Of course, most of the interest was focused on Egypt, but the decipherment of Egyptian hieroglyphs by the French philologist Jean-François Champollion in the subsequent decades allowed Assyriologists to correlate cuneiform texts against Egyptian texts. By the mid-1800s, Assyriologists had realized that the cuneiform texts were not all in one language. Over the following decades, they began to understand portions of Elamite, Babylonian, Akkadian, and Sumerian, partly due to diligent study and some guesswork, and partly due to a wave of archaeological expeditions that returned many more inscriptions that they could work with, particularly the excavation of the library of Ashurbanipal in 1849 and 1851. In 1857, 4 scholars claimed that they were able to read Akkadian texts, and these claims were put to a test. The secretary of the Royal Asiatic Society, Edwin Norris, selected an inscription of a newly discovered artifact and gave this inscription to the 4 scholars. They then independently translated the inscription and presented their translations to a panel of judges who determined how closely these translations agreed with one another. All 4 translations agreed in the overall sense of the text, and the translations of 2 of the more experienced Assyriologists, Henry Rawlinson and Edward Hincks, agreed almost perfectly with one another. Of course, this history is glossing over much that could be an entire podcast series in its own right, but for our purposes, things really get interesting towards the end of the 1800s, when the Assyriologist Hugo Winkler made the first attempt at deciphering astronomical texts. Winkler's initial interpretations were overbroad and proposed a vastly more sophisticated astronomy for the Babylonians than they actually possessed in the year 2000 BC. To be fair to Winkler, he was no slouch. He is better known for being the first to decipher the Code of Hammurabi after it was discovered in 1901, as well as the lesser-known but equally important Amarna letters after they were discovered in the early 1890s. The first correct interpretation of astronomical texts were done by a trio of Jesuit priests, Fathers Strassmayer, Epping, and Kugler. These scholars had some astronomical knowledge which allowed them to correlate patterns they saw in tables of characters and numbers against known astronomical phenomena, particularly the motions of Venus, which, as we will see in a later episode, held a special place in Babylonian astrology. And by the early 1900s, this work started to reveal some tantalizing clues as to when some of these inscriptions were written. Because in particular, one tablet contained descriptions of the positions of Venus, along with a line that reads, "Year of the Golden Throne." One of these Jesuits, Father Kugler, realized that this was not the only reference to the Year of the Golden Throne in ancient Babylonian texts. There were other non-astronomical texts which also referred to the year of the Golden Throne, from the 8th year of King Amizabduga. And this was not the only coincidence. Years which lasted 13 months in the astronomical texts lined up with the years lasting 13 months in the non-astronomical texts, and the astronomical text contained 21 years of data on the positions of Venus, which corresponded exactly to the 21 years of King Amizabduga's reign. Kugler realized that with modern astronomy, he could determine which year in the past Venus had that particular sequence of positions on the sky. This would then fix the year of the Golden Throne to a particular date in the modern Gregorian calendar. So Kugler went and did this. In one of the tablets from this year of the Golden Throne, there is a statement that on the 26th of the month Arach Sama, in the 6th year, Venus disappeared behind the sun in the west. On the 3rd of the following month, it reappeared in the east. Now, as you'll recall, the months in ancient Babylonia were not arbitrary. The beginning of the month always coincided with a new moon, at least approximately. The months had 29 days, so the midpoint of Venus's disappearance was the beginning of the month, and a new moon. This means that on that particular date, the beginning of the month of Kislevu, in the 6th year of King Amizabduga's reign, there was a conjunction between the sun, the moon, and Venus. And Kugler was able to figure out when this astronomical event had occurred in the modern Gregorian calendar, January 23rd, 1971 BC. The establishment of this date then fixed a whole host of other dates from ancient Babylonia. Using lists of kings and the duration of their reigns, historians could then determine that King Hammurabi reigned from 1848 to 1806 BC. Or so they thought. Over time, issues began to crop up with this dating. The average reign of kings would have had to have been fairly long in order to get it to work, or else there would have to be unknown gaps in the chronology. And more worrisome, later on, records of lunar and solar eclipses were discovered that did not seem to correspond to times that they could have been observed based on known astronomical data. The trouble here is that astronomical phenomena are periodic. Father Kugler used a conjunction of Venus with the sun and the moon to determine the date of the 6th year of King Amizabduga's reign, but these conjunctions occur every 56 or 64 years. So with astronomical data, you can determine the precise date that this event occurred, but only if you already know when it happened to within a half century. Today, most historians believe that this event occurred in 1638 BC, not 1971 BC. But it is still not known for certain. Archaeologists speak of a long, middle, and short chronology, as well as more speculative ultra-long and ultra-short chronologies, that each take a different date for this particular conjunction. And there is evidence for and against each of these chronologies. The general consensus is that the middle chronology is the most likely to be correct. If you look up King Hammurabi on Wikipedia or read about him in a book, the date that they provide will most likely be from the middle chronology. This matches well with several other non-astronomical records like king lists and dendrochronology best, but there are also smaller camps of scholars who favor the short chronology, which puts the beginning of Hammurabi's reign 64 years later in 1728 BC, as it seems to better match other astronomical observations like lunar eclipse records, though not all lunar eclipse records. And some have even favored the ultra-short chronology, which puts the reign of Hammurabi almost a century after the generally accepted middle chronology, at 1696 BC, since it seems to match the astronomical records best of all, but implies that there are major issues with the other dating techniques. At the very least, we can see that arriving at absolute dates in archaeology is a hard problem, and we will see in more detail in future episodes that this problem of measuring the ages of things in this universe that do not have dates attached to them is not limited to archaeology. Astronomers have been wrestling with this problem with perhaps even less evidence to go on than archaeologists for a long time. Well, that is all for this month. In the next episode, we will return to the astronomy of Babylonia and discuss the place of Venus and the other planets in Babylonian astrology, and begin to look at the development of mathematical astronomy with the Babylonian theory of lunar eclipses. Thank you for listening, and until the next full moon, good night and clear skies.